Hey everybody, Brian Garcia, meteorologist, National Weather Service, San Francisco Bay Area, Monterey Bay regions, here with the winter season 2024-2025 outlook. And you see their seasonal briefing late October long version. That's because this is going to be the nerdy version. This is the one that kind of sets the stage for all of the updates to come. So if you don't want the half-hour version here, I would encourage you to just skip forward, drag that little slider bar thing across the bottom, and like wherever you see like maps that show winter graphic looking type stuff, go to there and listen to the outlook at that point. Otherwise, there's a ton of information in this. I would encourage you to sit down, grab a cup of cocoa or coffee or whatever you need, and enjoy the presentation. So let's get right to it. So we are going to go over a ton of stuff, all of this stuff in gory detail. Last winter, 2023-2024, our precipitation across the Bay Area and Central Coast was just about normal. It's really impressive. Even with normal, though, we still had some impacts across the region. But you can see there are lots of yellows and oranges and greens. Those yellow, oranges, and greens are like essentially around 100%, anywhere from like 80% to like 110%. But once you get down to the Central Coast, you get down into Monterey County there, in the Santa Lucia Range, Los Padres National Forest, you see all those purples really pop, and even some bright purples. That's upwards of 150 to 200% of normal. In some places even above. There's one site there that says 243% of normal, which is just crazy. So you can kind of see where all the precipitation went last year. It was all down there, but it did spread nicely across the Bay Area as well. What that has done for our drought status was really impressive. 2 very wet years back to back. We were essentially a blank map this time last year, even going into last winter. And then last winter we had all that precipitation. We remained a blank map going into this spring. But then, of course, summer comes along, and what happened this summer is we got very hot. We had quite a few heat advisories and excessive heat warnings out this summer. And what that does, when we put heat on the vegetation as well as onto the soils, we get transpiration off the vegetation and evaporation out of the soils, otherwise known as evapotranspiration. And no, I didn't just make that up. It's a legit word. We had a lot of evapotranspiration. So these drought monitor maps only show what we're looking at in terms of meteorological drought and agricultural drought. So that's why we're just abnormally dry, is because we got so hot this summer, we dried things out. So abnormally dry. If we don't get rain soon, though, we might slide into that D1, that moderate drought. And I will say at this time that the federal government does not declare drought in states. That's up to the governor and the county of any counties in California. That's how they do drought in this state. So it's really going to be up to, let's say you live in Contra Costa County, it's going to be up to the governor and the governance of Contra Costa County to decide whether or not they're going to declare a drought in that area. So the U.S. Seasonal Drought Outlook, this is valid October 17th, which was its release date, right on through the end of January. You can see across our area, the Bay Area and Central Coast region, it's just a big nothing. And if you look down in the right for that big nothing, it just says no drought. So that is a good sign that we won't go deep into drought, which is wonderful through the at least the end of January. So we'll be watching that one very closely. So let's get into a little bit of the nerdy science here, and then we'll skip into the seasonal outlook. So the science. So these are some schematics of the El Nino Southern Oscillation, otherwise known as ENSO. In the upper left here, we see El Nino conditions. What happens in El Nino conditions is those trade winds across the equatorial Pacific, and you can see it says equator here, and it has this black line right on through. That's the equator. The trade winds really kind of die off, and it allows the warm sea surface waters to start to migrate to the east. And so we get warmer than normal sea surface waters in the eastern part of the equatorial Pacific. In conjunction with that, this convection, these thunderstorms, would follow that into different parts of the equatorial Pacific. Different meaning different from where they normally should be. So what this can do in circulations that extend north and south off of this convection zone, it can actually push more moisture into the subtropics in different longitudinal areas. And so with that, then we can get the extratropical jet, meaning the area of weather movement that impacts our region and areas north of us. That extratropical jet can actually dip down and grab on some of that moisture and move it into California. That's the reason El Nino conditions, when we get into El Nino conditions, we typically, and I'll throw that in quotes, we typically will see wetter than normal winters. Conversely, on the far right, the upper right here, this is the La Nina conditions. La Nina conditions are the opposite. You get some stronger trades across the equatorial Pacific, push the warm sea surface temperatures out over towards the western part of the Pacific. So think out towards Indonesia, and you can't have a void in the eastern part of the Pacific up against South America there. So conservation of mass and all. So water starts to upwell from the subsurface and fills in along the coast and across the eastern parts of the equatorial Pacific. That's called upwelling. It's cold sea surface, cold waters in the ocean, and so then we end up with anomalously cold sea surface temperatures over that region. And you can see that convection, those thunderstorms move over a different spot, and that will get picked up by the extratropical, in the subtropics by the extratropical jet in other ways, and it will move it in towards the Pacific Northwest. And so in La Nina conditions, we typically see a wetter Pacific Northwest and a drier Southwest, which we are kind of considered the Southwest in this type of scenario. And then, of course, normal conditions are what I like to affectionately refer to as La Nada. We see things just kind of balanced. Everything's kind of the way it should be. And that convection can ebb and flow left to right here a little bit, east and west, as the sea surface temperatures just kind of modulate in there. And so we can tap into that occasionally during a winter, which is good because then we can get some precipitation from what this is sending into the subtropics. So down in the bottom, what we're looking at are anomalies. So the one on the left is temperature anomaly. So in other words, the 2 meter temperature anomaly, like what you'd feel when you go outside. This is as of October 11th. And I just wanted to put this in there just because it shows a lot of warmth across the globe, some areas of cool on that day as well. So the blues are the cooler than normal, the reds and dark reds are warmer than normal. And I'll throw the plug in here. Look up across the Canadian archipelago, up across northern Canada, and even up across northern Europe and into Russia, like out towards Kamchatka area in Russia. Lots of red up in the Arctic, and no place is warming faster on the globe than the polar regions due to climate change. So this is a huge deal, and this is just a one-day snapshot. This is a one-day average. So don't take this as like, nah, I see lots of blues. That's just one day. If we looked at it as a composite over 30, 60, 90 days, you'd see red showing up, and especially over longer term, you'd see the anomalies really pop. Over here on the right, this is, again, a snapshot based against the 91 to 2020 averages there. And this is sea surface temperature. So sea surface temperature doesn't change as fast as air temperature. It takes a lot longer to change. It holds the heat a lot better. And I want you to take a look at this, because you can actually look at this and say, wow, there's a lot of red on that graphic. And that is, yes, it's a snapshot, but it takes a long time for the ocean to release that heat, so it holds it a lot longer. So this is what like a 7-day average would look like too. It'd look very similar. So especially like off of Japan, out over here, hopefully you can see my mouse, the Kuroshio current rips up across the southern end of the Aleutians there. It's anomalously warm, like crazy warm compared to what it should be. So that's a really just interesting thing to watch and to see how it transitions. Don't get me wrong, we get some big storms. It can churn the water in the vertical as well, and it can wash out some of these warm anomalies, especially in the more polar latitudes. It can wash out some of those sea surface temperature anomalies. But the underlying baseline conditions are that we're seeing a continued warmth of sea surface temperatures globally. And what that can do for us is provide warming of the atmosphere above it, and warming of the atmosphere above it means that we can actually hold more water vapor in the atmosphere, which then when it hits land, and especially mountains, gets squeezed out against the mountains, we can actually have bigger precipitation events during that time. So Just can't throw it all out there. All right, so La Nina. This is the typical La Nina pattern for the El Nino Southern Oscillation. Remember, ENSO encompasses everything, whether it's a La Nina, El Nino, or La Nada. But this pattern that you're seeing right here is a typical La Nina pattern, which means a wetter Pacific Northwest and a drier Southwest. California in this schematic is kind of in that nodal area. So it can be drier or wetter depending upon where that node shifts. So think of like the fulcrum piece, that middle piece, in a teeter-totter. In this schematic, we're kind of that middle piece. That middle piece can shift farther north or farther south as well. So I showed you La Nina because we are technically in a La Nina advisory, or sorry, a La Nina watch right now. So we're sitting in a La Nina watch. But every month that these models get run and come out, it shows us going less and less into a La Nina. So let's orient you here really quick. So on this graphic, you're going to see this black dot out over here on the left. That is an observation point for the season of July, August, September. So that JAS down here on the bottom, that is an observation over the composite of those 3 months. This gray square is an observation just for the month of September. So you can see that slight downtick here, and then the models run out, and they effectively, if you blur your eyes, they continue down towards that kind of dashed line here. And that dashed line is very critical because that is a minus 0.5 sea surface temperature anomaly for the area in the equatorial Pacific that we watch for La Nina or El Nino to emerge. And we're looking at a cooling of that area, but it just kind of flirts with that dashed line in the models and then really starts to pop back up. So this is going to be really interesting to watch over the next few months to see how these trends occur in the equatorial Pacific and how the models respond to those as well. Because right now it looks like we're either going to be on the cool side of a neutral event or a La Nada event, a cool La Nada, or we're going to dip into a legit La Nina, but that La Nina will be a very, very weak La Nina. So what can a weak La Nina look like in terms of precipitation patterns? This graphic shows strong in the row up top, moderate in the row in the middle, and then weak in the row in the bottom. And the thing to focus on here is brown is dry, green is wet. And so if we just march through here, you can see 64, 65, maybe had a little wet up in North Bay, Marin, Sonoma County. And then when we get to 95, 96, a very wet bulk of the state. And then again in 05, 06, pretty much the northern half of California was on the wet side. But all of the other events of weak La Ninas have been drier than normal. So that's when we talk about probabilities. So if we dip into a weak La Nina, our probability is higher to be drier than normal. That said, remember those models in this last slide, we can end up being in a cool side of the La Nada, the ENSO neutral. So then it's really kind of all bets are off. So it's interesting to look at this, and we'll get into the seasonal outlook here in just a moment. But when we have weak events, other factors play a role. So we get into what we call intra-seasonal variability. That simply means that we get variability, these other signals that occur within the winter season. And two of the ones that we watch, and I should have probably put a third as well, but we watch the Mann-Julian oscillation on the left and the Arctic oscillation on the right. We also watch the Pacific North American index, the PNA, just to kind of give us an idea of what might be occurring over the next week or two based on these intra-seasonal signals. So these intra-seasonal signals are very interesting. So on the left, it's an idealized schematic of precipitation distribution across 30 north to 30 south around the world for Mann-Julian oscillation, and essentially it tells us where the thunderstorms across the equatorial region reach up into the subtropics. So think towards Hawaii, where those reach and when it might get picked up by a mid-latitude jet, so a big old trough that drops down, a big old cold front that drops down towards Hawaii and picks it up. And that is where we can really tap into some of that subtropical moisture and get significant pineapple expresses or atmospheric rivers. So over on the right, the Arctic oscillation, You can see that negative phase shows the blue out across the eastern Pacific here. That means that it's generally low pressure out there, whereas the positive phase, it has generally high pressure. So in that negative phase, that's when we can really tap into things. So when we line the Madden-Julian oscillation up with the Arctic oscillation, we can really tap into some of that subtropical moisture and bring in some significant amounts of rainfall. So when the El Nino Southern Oscillation ENSO is on the weaker side and the signal isn't very strong, we watch these other intra-seasonal variability signals very closely to give us an idea of what might be coming in the next week or two. So there's some nerd out for you. So let's get into the outlook. So first we're going to look at the monthly outlook for November, and all these charts that you're about to see all were issued on October 17th, so last week. On the left, you'll see temperature outlooks. On the right, you'll see precipitation outlooks. You see above, below, and equal chances in there. Above, different colors of above simply means the probability of being above normal for whether it's temperature or precipitation. And then below simply means, depending upon the color, the shade of the color, simply means that we have a certain probability of being below normal for whether it be temperature or precipitation. And equal chances is the meteorological equivalent of a shrug. It literally means that you have a 33.3% chance of being above, below, or near normal. There's just no clear signal that indicates one way or another at this time. So that's when you see equal chances come up. So for November, I want you to really see this in the precipitation on the right. Pacific Northwest, higher probability of being above normal for precipitation. Southwest, Arizona, Nevada, higher probability of being below normal for precipitation. That is a classic La Nina signal right there. And then, of course, that nodal area, that kind of fulcrum between the two sides of the teeter-totter, right in the middle, equal chances. Hello, California. So now let's take a look at some seasonal stuff. So we're going from monthly to seasonal. If you remember right, seasonal, we're looking at 3 months at a time. So this is November, December, January. Look at the temperatures on the left. Temperatures on the left, we start to pull in those equal chances. That means we could get some cold temperatures moving through the area as well as some above normal temperatures. So the probability spread is spread across the board there. Precipitation, same thing. Probability spread is across the board, equal chances on either side, above, below, or near normal. So it's really challenging to say exactly what's going to happen in this time frame, given that we're in either a cool La Nada event or a very weak La Nina event. And then as we get into December, January, February, this is our core wet months here. Equal chances for temperature, and you see those below normal, so it's higher probabilities of being below normal for temperature in the Pacific Northwest and across the northern part of all the way to the northern plains, really, and a higher probability of being above normal for precipitation across the Northwest. Then it just slides down into equal chances across California. But with the stuff happening, the storm track up in the Northwest, it tells me that we can see some of those storms drop south, bring significantly colder temperatures. We will have cold snaps this winter. It will get cold, and we will have rain because some of those storms from the Gulf of Alaska will sink through our area. It's just a matter of whether or not we can actually tap into some subtropical moisture and get a legitimate Pineapple Express / atmospheric river through our region. We get into the January, February, March timeframe, same type of look as the December, January, February timeframe, except the precipitation, you see that in January, February, March, starts to sink a little bit farther south into California, so now we have a higher probability of being above normal for precipitation, going as far south as Mendocino County there along the coast. So it's going to be very interesting to see how this plays out, but this tells me that there is a leaning towards February and even into March for some storm track change. So we'll have to watch that very closely as we get into after the new year. Does that mean we won't have storms in November, December, and even in January? Absolutely not. We will have storms. It's just I don't expect any big whoppers of storms at that point. But come on, atmosphere, surprise me. February, March, April, again, equal chances across the board. There's no clear signal, but you can see the split from north to south. That is a clear La Nina signal. The Climate Prediction Center is still leaning towards La Nina actually taking hold and having that typical pattern show up. And even to March, April, May, you can see those below temperature, higher probability of being below normal for temperatures up north and higher probability of being above temperatures for the south. That's a clear La Nina signal, and even below for precipitation in the desert southwest as we get into this time. As we get into this time for California, the precipitation normals really drop off anyway, so being equal chances really doesn't matter because the difference between being above or below normal really isn't that great. That spread isn't that great. I will say that with some of the cooler temperatures up north, and if we get some of those fronts even dropping through in the spring, we could see some pretty decent thunderstorms move through the region, which could lay down some decent amounts of hail as we get into the spring. So that's something we'll have to watch. And even this last spring, late winter and early spring, we had some pretty significant thunderstorms roll across the area. A couple that we issued severe thunderstorm warnings for, and one that we actually had a tornado warning for. So it does happen here. It's rare, but it does happen. So some other winter threats. King tides. This is essentially the highest astronomical tides of the year. These also happen in the summer months. It has to do with the sun and moon alignment and where they are in relation to the Earth. So we do get big tidal swings in the summer as well, but the big high tides happen overnight. So a lot of people don't see them. In this case, the high tides actually happen during the day, so people see them and their impact. And you can see by this picture from the California Coastal Commission, Highway 101 on-ramp and off-ramp there at Sausalito is just underwater. And that's where water shouldn't be, especially as we get more sea level rise. We're going to start seeing these impacts more and more. We'll see these king tides return mid-November, then again mid-late month in December and mid-late month in January. High surf's another one. So if you live in a coastal county or visit a coastal county or like to recreate out at the beach or like to go visit the beach, just be careful. Check the forecast. Ask officials, like if you see a police officer or fire, especially fire since they do a lot of water rescues, ask them if the conditions are safe to go down to the beach, and especially if you have kids, make sure that you're safe with your children down at the beach. And if you have little ones, put them in life jackets. It's better to see them floating out there and a little chilly than actually be succumb to the ocean. Too many sad stories like that. So let's keep those sad stories a thing of the past, and let's have a good winter. So be careful down at the beach. So when you put everything together, we can get some coastal flooding and erosion. So we get big surf, we get high tides, we get storm surge, and we get rain runoff. You can end up with a pretty significant area of flooding, like right at the coast, because of all of them coming together. And the ones I think of, excuse me, I need a drink of water. The ones I think of are Capitola and Stinson Beach, beginning of 23 and the end of 2023. They had some big surf come in with some higher tides and some storm surge and flooded into those two cities. So it's pretty rare, but unfortunately as the sea level rises and as we get some bigger meteor storms across the Pacific, we could see that occur more and more. So some hazards that we trigger alerts for. So flooding, of course, is one of them for rivers, and then, of course, heavy rain. So we'll issue flood warnings or flash flood warnings. Then post-wildfire debris flows, if we have big burn scars like we did back in 2020, and we have burn scars, we can issue flash flood warnings for post-wildfire debris flows. Thankfully, we haven't had any burn scars yet in our area that require or necessitate us to think about that for this year, so that's good. Like I talked about with severe thunderstorms and tornadoes, we issue warnings for both of those, and we did that earlier this year. We had some pretty good weather roll through our area. It's not just for the Midwest anymore. We can get it too. Snow is rare across our area, but in the winter of 22-23, that picture on the bottom right there, that's up on Mount Umunum in the Santa Cruz Mountains. That's our radar, and we legit could have had a blizzard warning out for them because this little twig over here on the bottom left was a power pole at one point, and the wind snapped it off. So it got really windy up there and knocked power out to the radar. Thankfully, we have a generator up there, but we can issue blizzard warnings if necessitated, and winter storm advisories and warnings as well. Wind is another one. Unfortunately, wind kills a lot of people, whether it's honestly just people out on their daily walk and a branch breaks because of wind and drops on them and knocks them dead. It happens far too often, unfortunately, and then trees falling on houses, big branches falling on houses or cars. So, in short, know your area. If you have a dead or diseased tree in your area, it's best to get that checked by an arborist and get that taken down if you can, because that could be a life safety issue. Cold temperatures, of course, are always life safety issues for our unhoused populations, our partially housed, those people living in cars, or those who are inadequately housed, meaning people who just, don't have insulation in their homes like me. And then they, if you have to make a choice between food or warming your house, it can be a life or death situation. So cold temperatures are a legitimate thing. So we do issue frost advisories and freeze warnings. Used to really be for the agricultural industry. Now it's really, we're leaning towards the protection of human life with this, as well as animal life as well. And then dense fog advisories, we put those out, especially as we get the fog rolling in from the Central Valley out through some of the coastal gaps and getting into our area. We can get that Thule fog moving into our region. So here's the definition of watch advisory warning. So warning and advisory essentially mean that the threat is imminent or occurring, meaning that it is happening right now or we see it coming. And the warning is the highest tier here. So the way I like to put it is an advisory means that it's, like I said, imminent or occurring, and that you're going to have to go find trouble. Warning, again, imminent or occurring, and that trouble's coming to you. So if you hear a warning, you should really be paying attention and looking to see how it could impact exactly where you're at. A watch is just that. That means we're watching out for this. That means conditions look like they're going to be favorable for something to happen, but we just don't know yet. Everything hasn't quite come together. So have an action plan for that type of thing. We've made some changes nationwide to our extreme cold and freeze products. We don't use a lot of the extreme cold stuff, so I'm just going to leave that for you to digest with your own eyes. And then the freeze side, so the watches are being consolidated. Instead of hard freeze watch or freeze watch, just a freeze watch now. And instead of a hard freeze warning, a freeze warning, now we just have freeze warning. So those are the changes, essentially just collapsing them into singular things. So hopefully they'll be easier to digest and understand. Other resources that are out there that you can use, California Nevada River Forecast Center. Check this out. URL is at the bottom. And you can look at a lot of different rivers. In short, a little quick tutorial, that blue line there, that dark blue line, that is observation. That green line is a hydrologist, meteorologist forecast for that river. Of course, it's flat here because we don't have anything running right now. And then that magenta line is model forecast out. So the human touch part is that green one. So if you have a river near you that actually has a forecast point for it, go check it out and watch it. It's pretty interesting. So there are a few of them like the Guadalupe, Coyote Creek, Napa, Russian, those types, San Lorenzo and Santa Cruz County. So all those different types of places you can watch that. The California Nevada River Forecast Center up there in Sacramento does have some changes to their stages. So the current stages are monitor, flood, and danger. They are going to this winter a monitor stage still, so it's an action monitor stage, and you can see the definitions out there over on the right. Then flood stage is going to be discretized into 3 separate flood stages, so minor, moderate, and major flood stage, and then that danger stage is slowly going to be phased out because major is really taking that over. The National Water Prediction Service is another place you can go. This is really a collection of all the stream gauge data that we can find across the area, put into one spot, and this comes out of the National Water Center in Tuscaloosa, Alabama. So just go to water.noaa.gov, and you can see all sorts of stream gauges across the area and follow how they're changing in time there. You won't see the forecast for all the places necessarily, but you will see data for all the gauges that are currently operating. Of course, other resources, our webpage, weather.gov/Bay Area, as well as weather.gov/forecast points. Forecast points is a really amazing page, really easy and simple to navigate. Just zoom in, click on your spot, and then scroll down, look at the forecast. It makes it really nice and simple. But if you want a deep dive, then weather.gov/Bay Area, or just in general, weather.gov, you can do some deep dives into some items. Of course, we're on the main socials, so you're watching this here on YouTube. And then, of course, we are on Twitter, otherwise known as X now, apparently. And then we also have Facebook. So please follow us on all those platforms. And if you have weather pictures of ongoing weather, we love to see those during the event. Just get pictures safely and send them up to us safely. We're not the only office that services California. There are 10 forecast offices that service California, and we are all here to provide weather, water, and climate intelligence to all of our partnering agencies. And we partner with people from other federal agencies to state agencies, county, local jurisdictions, nonprofits, non-governmental organizations. So we partner with a lot of people for our area across 11 counties, and we have great partners, and they care about each and every one of you and want to make sure that you get the information that you need to take the protective action to protect yourself and your family and your loved ones. So with that, I'm going to say this last thing. No matter what I say, no matter what anybody says, no matter what you hear out there, it really just be ready for anything. You saw a lot of equal chances today. That means you've really got to be ready for everything, because we will probably get a couple whopper storms through the area. Who knows exactly where in the area we're going to get hit by them. But if you're ready for that one big one where you lose power, you might lose access to clean drinking water, and who knows, cascading impacts could occur. The Hayward Fault could rip too during. Just be prepared, and you'll be ready for most anything. And have ways to communicate with your friends, family, and loved ones. It's really important to make sure that everybody's safe. Finally, I'll say, of course, take care of yourself, take care of each other, and be good to one another. See you, everybody.